Okay, question 5. We are doing a bit of trig and we are differentiating something, it looks like. So let's have a look. We are given that y equals 3 sine theta over 2 sine theta plus 2 cos theta. And we're given a restriction here for the values of theta. Fair enough. Show that dy by d theta equals some constant a, which I think we've got to find, over 1 plus sine 2 theta. It's a show that. We love a show that because we know what we're trying to get to. Alright, so we're aiming for this, where a is a rational constant to be found. Okay, differentiating this here, we have a fraction, so it's probably going to be the quotient rule, which I have put here. You need to know the quotient rule. Alright, this is a nice, somebody came up with this, and a lot of students use this. Is it ho d high minus high d ho over ho ho. It's just an easy way to remember how to set it up. Alright, the proper notation is up here. So we're going to have two parts to this. Normally people use u and v, don't they? So u equals our f function and v equals our g function. So we'll do that because that's the most popular way that I see it used. All right, so u is 3 sine theta, sorry, and v is this whole thing on the bottom. So we've got 2 sine theta plus 2 cos theta. Got to be so careful with these questions because it's so easy to make a mistake. Right, other parts of the formula, we need to differentiate our u. So if we do a u prime, so differential of u, what does sine differentiate to? Well, that differentiates to cos. You need to know that as well. Okay, you should know that if you're doing exam question practice, you should know this off by heart by now. We're differentiating sine and cos again. So this is just going to be 2 cos theta, and cos differentiates to minus sine, so you have minus 2 sine theta. That's going to be your differential of v, okay? So we're going to put this into the formula now and set it up, and then it looks like it's going to be an algebraic nightmare and you're going to watch me struggle with it, but let's see how we get on. Fingers crossed I don't have to do about 55 takes on this one. So the part of the formula is, it's ho times d high, so we've got the g function, which we said was the v part here. So we're going to have v on top, so we've got 2 sine theta plus 2 cos theta multiplied by the differential of the u function, which we said is 3 cos theta. Okay, so I'll just write it out, 3 cos theta. 3's disappeared. 3 cos theta minus the u term, which we said u is just 3 sine theta. Okay, multiplied by the differential of the v, so differential of v is 2 cos theta minus 2 sine theta. This is going to be fun. All over, v squared. So v squared is this squared. I think I'm going to need to start trying to write a bit smaller here. So, excuse me while I take a bit of time over this, because I'm very conscious there's going to be a lot of work expanding all of this and trying to fit it onto this screen here. Okay. Alright, so that's the setup. Probably going to get marks for setting it up initially like that, and now we've got to expand. I can imagine it's going to be a big expansion with a lot of terms cancelling out. So let's just take our time with this one. Let's multiply out this first bracket here. So I've got 2 times 3, which is 6. And then I've got sine theta times cos theta plus 6, oh that's nice, cos squared theta, that's a nicer term, minus 6 sine theta cos theta, just take it one term at a time, minus 3 sine times minus 2 sine theta is going to be plus 6 sine squared theta. That is a very nice term there. You can see a plus 6 cos squared theta and a plus 6 sine squared theta. Excellent. Bottom bracket, multiplying this out, I'm going to kind of do it all in one go. So you're going to get two lots of this bracket times each other. Is everyone aware of that? Yeah, it's 2 sine theta plus 2 cos theta times another bracket of 2 sine theta plus cos 2 theta. So we're going to be like doing quadratic again. 2 sine theta times another 2 sine theta, which will be written here, is going to be 4 sine squared theta. Where has that disappeared to? It's a nightmare, this new pen. And then I'm going to get two lots of these two terms times together. So I'm going to end up with 8, if I do this all in one go, 8 sine theta cos theta plus, and now I'm going to get 2 cos theta times 2 cos theta, which is 4 cos squared theta. Okay, loads of stuff going on here. Terms that will cancel. This 6 sine theta cos theta minus 6 sine theta cos theta is 0. You've got 6 cos squared theta plus 6 sine squared theta. If I do a factorisation of that, it's more obvious what's going to happen there. So you're going to end up with 6 times cos squared theta plus sine squared theta. Just factored out the 6 from what's left on the top. And that's going to be 1. 6 times 1 is 6. So I'm going to start a new bracket over here. 1. This is good. Starting to get a constant here with nothing on top. Over. Now over, what's the bottom looking like here? We've got the same thing happening here. If I factor out the 4 from this term and this term, I'm going to get 4 times sine, sine squared theta plus cos squared theta, which is 4 times 1, which is just going to be 4. Oh, actually, that's not 1, is it? That's 6 times 1. That should be a 6. Luckily, I spotted that just in time. 4 times 1 is 4. That's in that position. And I've got this plus 8 sine theta cos theta. I'm trying to get sine 2 theta, and I know my double angle formula, which we all should know. Sine 2 theta is the same as 2 sine theta cos theta, but I have got 8 of these. I've got 8. So we need to times by 4 both sides. Times this by 4, and we get 4 sine 2 theta is equal to 8 lots of sine theta cos theta. Right, so that is going to become, that bit there is going to become 4 sine 2 theta plus 4 sine 2 theta. I can factor out the 4. I'm going to have to be a little bit bad on my presentation here. I'm running out of space. I'm going upwards. Here we go, we're going up. So we're going to have 6 over 4, factor out the 4, 1 plus sine 2 theta, which is the format that we want. Okay, this is the format that we want. A is just going to be the term in front of all of this. So our A is this part here. This is our A value. 6 over 4. So I've got no way to write this. Sorry about this. I'll put it up here. A equals 6 over 4, which can be simplified to 3 over 2. for no good reason apart from it looks nice. Okay, there we go.